Since the time now is 1:30, I think we can just start. Well, I myself would use a timer, and well, basically, all of each speaker in the first part you will have 15 minutes, and then I'll set the timer to about 40 minutes, and you may hear the beep sound when it's close to 14 minutes. And I will try to turn on my video to let you know that you're close to the end of 13 minutes or 12 minutes. Okay, shall we have the first speaker? First speaker to just go ahead to do the presentations. JD Kanchana. Okay, yeah, thank you. And yeah, so if you're ready, please feel free to go ahead.
Hello, good afternoon everyone. I'm JD Kanchana and my co-authors are Dr. Gayashan Amarasinghe, Ms. Vishaka Nanayakkara, Dr. Amal, Shehan, Perera. We present a data mining approach for early prediction of academic performance of students. It's a known fact around the world that not all students who enroll into university do graduate. In United States, which ranks in 19th place for graduation rates among OECD studies, the dropout rate is 40%. Then what about countries which rank in lower positions than US? What is their dropout rate? The dropout rate from universities or schools is a serious problem. The students may drop out due to various factors such as financial difficulties or low performance. Students with low performance, they might face motivation problems in proceeding with the degree. So we understand one solution towards this dropping out problem is to, as early as possible, identify who are the students who are likely to fail. To identify the low performers, first we have to predict the future student performance. Mostly now, data mining and machine learning is used in the educational sector. In the classroom-based learning and online learning, flipped learning methodologies are being used. There are even learning analytic-based tools with virtual reality and stimulations used in military training and pilot-based training. But there's a question around the user-friendly nature of these tools. How user-friendly are they? The more user-friendly a tool is, the more likely teachers and students will use that tool, since we can't guarantee all the teachers and all the students are IT literate people. As per our literature study, we have identified that the rate of completion of assessments and previous academic performance of students significantly affects to the student performance. Scholars have studied student performance with respect to demographic factors, and some scholars have excluded demographic factors. So there is a controversy around the use of demographic factors to predict students' performance. In previous academic performance, we can take into consideration their school-wise grade of marks, or even if they are enrolled to university or that school, the previous semester-wise grade, mark, or even a GPA. Tata et al., in an attempt to predict the students' performance, says that at early stages, using the students' subject grades or marks can predict the student performance, and after a few terms to use the GPA to predict the future student performance. In this study, there is a bit of question around what is that early stage exactly as a semester or a term. So we can accurately predict the student performance. Asif et al., in her study, they have identified from year 3 onwards, student performance can be predicted. Low performers are students who are normally having a difficulty in catching up with the rest of their colleagues. So year 3, at that year 3 and year 4, relatively the subject modules are difficult than year 1 and year 2. So at year 3 and 4 onwards, to correct the low performance students to a average or at least high performance level, it takes an extra effort. So we need a semester or term that is earlier than year 3, which is semester 5. So that is where our motivation lies. We realize that there is a problem around the high number of students drop out. Then one possible solution is that can cause a huge impact by identifying the weak performance. For that, we need to correctly predict the students' performance. Any delay in predicting the student academic performance, the students, there will be affect students, how we can assist the weak performance will also be delayed. Our research objectives are as early as possible to predict the students' academic performance with reasonable accuracy, and out of the data attributes considered, which attributes play a contributory role towards the prediction of students' academic performance. In our considered data set was from computer science and engineering stream from a prestigious state university in Sri Lanka. They are from the academic batch 2015-2016, 126 students were there, and there was one repeat student. The privacy of the students were maintained by pseudo-anonymization of the original data. And there was one record of student with 3 column values missing, so we had to disregard that student record. So now 126 data records are there. At graduation, if a student earned between 3.7 and 4.2, that student gets a first class. A GPA between 3.3 and 3.7 gets a second upper class. 2 and 3.3 gets a second lower, and GPA less than 2 gets a pass. So our considered data set was from
recording in progress.
Our considered data set was from computer science and engineering, and the students in the academic year 2015-2016, 126 students were there, and there was one repeat student. Individual privacy of the students was protected by pseudo-anonymization of the original data. There was one student record which had 3 columns missing, so we had to disregard that student data point. So now we have 126 student records. At graduation time, if the student gets 3.7 and 4.2, a GPA between there, he gets a first class. A GPA between 3.3 and 3.7 gets a second upper class. A GPA between 2 and 3.3 gets a second lower class. A GPA less than 2 gets a pass. For a student to obtain at least a pass, the student has to get at least C grade in all the subjects enrolled for. If the student didn't get a C, he has to repeat and somehow get at least C for all the subjects. So this is our at time of graduation the grade distribution. There were 2 students having incomplete status, that means they have 1 or more repeat subjects. When a student writes as a repeat student, the maximum grade the student is eligible for is a C grade. In that 2 students, one student had a GPA of pass and another had the GPA of second lower. So we put those 2 students into those respective classes. Now we have only 4 classes. Still we can see in the second lower and pass classes there is a class imbalance problem. So we applied SMART and we increased the data points of those 2 minority classes. Now our entire data set has 172 data points or student records. In our data set, we considered the attributes gender, hometown district, medium of instructions, Z-score, semester GPA. The students in the considered data set came from 19 unique hometown districts. The student before enrolled to the university has to face a very competitive GCE advanced level exam. Then they can write that exam in either English, Sinhala or Tamil medium. So there are 3 categories. The university admission exam score is called Z-score. It is a continuous value ranging from 0 to 3.00, and semester wise GPA goes from 0 to 4.2. So for the machine learning models, they don't understand ABC like that, they understand in ones and zeros. So rather than saying male female, we label encoded it to ones and zeros. For hometown, district and medium of instructions, since there was more than 2 options, we had to one hot encode. For example, say medium of instructions is English for that student. For the English column, the students get 1, and for the Sinhala column 0, Tamil column 0. A student with Sinhala, one hot encoding. For the English column, that student gets 0. For the Sinhala column, he get 1. For the Tamil column, he gets 0. And Z-score and semester-wise GPA, their ranges are not exactly the same, so we had to use min-max normalization. From the machine learning models, we use decision tree, naive Bayes and SVM. Decision tree because the end result is easily interpretable with the decision tree. That is, in a sense, easier for the final teachers or students who are using. We use decision tree with a depth from 3 to 7 and against the criteria entropy and Gini index. And we use naive Bayes and SVM per the literature. They have stated that high performance is obtainable in the prediction of the student performance. SVM, we used radial basis function kernel. So these are our attributes. Now we use 7 data sets. You can see D1 to D7. They have used all the attributes we have mentioned: gender, hometown location, medium of instruction, Z-score or the university admission score. D1 uses only semester 1 GPA. D7 uses semester 1 up to semester 7 GPA. So these D1 to D7 respectively follow, including the each semester wise GPA. In dataset D8 to D14, we only used university admission exam score and the semester wise GPA. We excluded gender, hometown location and the medium of instruction. As per our results, you will be able to understand why. So this is the key, elaborating the abbreviations. As per our decision tree, this was the heat maps we obtained with the Gini index and the entropy. And you can see that even in semester 1 we got accuracies above 50 on going to predict the final student performance, whereas by semester 2, the D2, we got accuracies above 70. Then semester 3 we got accuracies above 75. We plotted the decision tree for semester 7 with the depth 7, and this is based on the criteria entropy. Here the root node is semester 3 GPA. Then we can identify semester 3 plays a contributory role towards the future prediction of student performance. Even with the Gini index criteria, this was further justified that semester 3 GPA plays a contributory role because they are also the root node is semester 3 GPA. But in both those, in here we identified Z-score or the university admission mark is playing somewhat a role. Also, we identify the hometown location of student is playing somewhat of a significant role. So based on both those decision trees, we identify semester 3 play a significant role. So we plotted the semester 3 decision tree also. Here we used entropy criteria because against the Gini index, entropy accuracies were better. Here we identified that again university admission score play a role, and the hometown and the medium of instructions. With the naive Bayes and SVM, we plotted accuracy, recall and precision graphs. So you can observe there are these curves with accuracies greater than 70, some even reaching 90% and greater. That those graphs used this they were results of datasets D8 to D14, which had excluded gender, hometown location and medium of instructions. The two that's below, so they were the datasets D1 to D7. They had gender, hometown location, medium of instruction. alongside Z score and the semester wise GPA. So from these graphs also again we are justified. By semester 3 onwards we can predict with a reasonable accuracy the students' final performance. So our study concludes that from semester 3 onwards, student overall performance can be predicted with a reasonable accuracy of above 75%. And we identified that semester-wise GPA and university admission roll play a significant role towards the future prediction of the student performance. Here it is important to note we use semester-wise GPA rather than cumulative GPA. Also, we identified residency of student and the medium of instruction of the university exam also play a contributory role. And here we identified gender does not affect the student's final performance. So, a limitation of our research was we used a somewhat small data set. We have already requested the Department of Examination for a data set including other departments of the engineering faculty, not only the computer science and engineering. And we have requested the Department of Examination for the student subject marks also. I would like to take this moment to thank TALE 2021 committee for the funding support, and I thank my supervisors Dr. Gayashan, Ms. Vishaka and Dr. Amal Shehan Perera, and I thank my parents and Mr. KDM Javardhana for the motivation to proceed with the research. These are the references I used. Thank you.
Okay, thank you, the speaker for the presentation. Since we have delayed a little bit, if there may be one or two very quick questions from the audience. So perhaps we have one quick question from an audience member about the students' high school. So will the speaker want to give any quick response on the questions?
Yes, so from the high school we couldn't get any results, but university admission entrance score, ESET score, we had considered that.
Okay. One last quick questions. No. In that case, then since we have about 5 to 6 minutes delay, we can just move on to the second presentation. So again, we'll have 15 minutes, and I will turn on my video camera when it's close to the last 3 minutes, and then you may hear some beep sounds when it's the last minute to give all presentations. Yeah, thank you.